The Underwriters Laboratories or UL Category KDER listing pertains to systems and devices utilized for grounding and bonding electrical setups. It encompasses items that establish a dependable electrical link between the grounding electrode conductor and either the grounded conductor or the equipment grounding conductor. The copper water pipe setup employing O-ring fittings, as detailed, presently lacks inclusion in the UL Category KDER listing. This absence signifies that UL hasn't assessed and certified its suitability for grounding and bonding applications. Inspectors might express apprehension regarding the efficacy of these O-ring fittings for grounding and bonding, primarily due to the absence of a UL listing, the potential for the O-ring to deteriorate over time, compromising its sealing capabilities, and the possibility of unintended crimping or damage to the pipe, potentially disrupting the electrical connection. To mitigate these worries, certain inspectors might mandate the placement of bonding jumpers at each joint within the water pipe network. These jumpers introduce an extra route for electrical current transit, thereby guaranteeing consistent grounding and bonding. The viewpoint that the O-ring fittings adequately bond the water pipe within 5 feet of the entrance might hold merit, but it doesn't resolve the apprehensions raised by inspectors. Devoid of a UL listing, there exists no certainty that these fittings adhere to the mandatory performance benchmarks for grounding and bonding. The acceptance of copper water pipe incorporating O-ring fittings for grounding and bonding isn't universally widespread across all regions. Specific areas might enforce local statutes or directives that either prohibit or curtail its utilization. Consulting with local authorities and a proficient electrician becomes imperative to ascertain whether this system gains approval within a specific locality. Until the copper water pipe system featuring O-ring fittings secures a UL Category KDER listing, exercising prudence dictates adhering to inspectors' suggestions and integrating bonding jumpers at every joint to ensure dependable grounding and bonding. The importance of grounding and bonding in electrical systems cannot be overstated, as they are critical for safety and proper equipment operation. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protective devices like circuit breakers and fuses to quickly interrupt the circuit and prevent electrical shock hazards. Bonding, on the other hand, ensures that all metallic parts of an electrical system are at the same electrical potential, minimizing the risk of voltage differences that could also lead to shocks. The National Electrical Code or NEC provides comprehensive guidelines for grounding and bonding, and compliance with these requirements is essential for all electrical installations. Section 250.4 of the NEC, for example, outlines the general requirements for grounding and bonding electrical systems, including the need to create a low impedance path to ground and to bond all metallic parts that could become energized. The UL Category KDER listing is a specific certification that verifies that a product meets certain safety and performance standards for grounding and bonding applications. Products that are listed under UL Category KDER have been tested and evaluated to ensure that they can reliably carry fault currents and maintain a low impedance connection to ground. When inspectors require a UL Category KDER listing for a grounding or bonding product, they are essentially seeking assurance that the product has been independently verified to meet the requirements of the NEC and other applicable standards. In the absence of a UL listing, inspectors may require additional measures, such as bonding jumpers, to ensure that the grounding and bonding system is adequate. Bonding jumpers are typically installed around joints or connections in metallic piping systems to provide a redundant path for fault currents. This is particularly important in situations where the joints or connections may not be reliably conductive due to corrosion, loose connections, or the presence of insulating materials like O-rings. The size of the bonding jumper is typically determined by the size of the equipment grounding conductor serving the circuit, as specified in NEC Table 250.102 Current. The jumper must be large enough to safely carry the available fault current without overheating or melting. In the case of copper water pipe with O-ring fittings, the O-rings themselves are a potential source of concern because they are made of an insulating material that can interrupt the electrical continuity of the piping system. Even if the crimped connection between the pipe and fitting appears to be tight and secure, the O-ring may prevent a reliable electrical connection from being established. This is why inspectors may require bonding jumpers to be installed around each fitting to bypass the O-ring and ensure a continuous grounding path. Another potential concern with copper water pipe with O-ring fittings is the long-term reliability of the connection. Over time, the copper pipe can corrode and the O-ring can degrade or become brittle. This can lead to a gradual increase in the resistance of the connection, which can compromise the effectiveness of the grounding system. For this reason, it is important to periodically inspect and test grounding connections to ensure that they are still in good condition. The NEC requires that grounding and bonding connections be accessible for inspection and testing, and it also specifies methods for verifying the integrity of these connections. One common method is to use a ground resistance meter to measure the resistance between the grounding electrode and various points in the electrical system. A high resistance reading indicates a problem with the grounding system that needs to be addressed. In addition to the NEC, local codes and regulations may also impose specific requirements for grounding and bonding. It is important to be aware of these requirements and to comply with them when installing or modifying electrical systems. Local codes may, for example, require the use of specific types of grounding electrodes or may specify minimum sizes for grounding conductors and bonding jumpers. They may also require that grounding and bonding systems be inspected and approved by a local electrical inspector before the system is put into service. The use of copper water pipe as a grounding electrode is permitted by the NEC, but there are certain restrictions. Section 250.52a of the NEC allows a metal water pipe to be used as a grounding electrode if it is in direct contact with the earth for at least 10 feet and is electrically continuous to the point of connection to the grounding electrode conductor. However, the NEC also requires that the metal water pipe be supplemented by an additional grounding electrode, such as a ground rod or ground ring. This is because the water pipe may not always be a reliable grounding electrode due to factors such as corrosion, breaks in the pipe, or the installation of non-conductive fittings or sections of pipe. When using a metal water pipe as a grounding electrode, it is important to bond the water pipe to the electrical system at the point where the grounding electrode conductor connects to the water pipe. This bonding connection ensures that the water pipe is at the same electrical potential as the rest of the electrical system, which helps to prevent voltage differences that could lead to shocks. The bonding connection must be made with a listed bonding clamp or fitting that is suitable for use with copper water pipe. In some cases, it may be necessary to install multiple bonding connections to ensure that the water pipe is adequately bonded. The location of the bonding connection is also important. The NEC requires that the bonding connection be made within 5 feet of the point where the water pipe enters the building. This is to minimize the length of the unbonded section of pipe, which could become energized if a fault occurs. If it is not possible to make the bonding connection within 5 feet of the entrance, an additional grounding electrode must be installed at the entrance. The NEC also addresses the grounding and bonding of other types of metallic piping systems, such as gas piping and compressed air piping. These piping systems are not permitted to be used as grounding electrodes, but they must be bonded to the electrical system to prevent them from becoming energized. The bonding connections must be made in accordance with the requirements of the NEC, using listed bonding clamps or fittings. In addition to grounding and bonding metallic piping systems, it is also important to ground and bond other metallic parts of an electrical system, such as metal enclosures, raceways, and equipment frames. These metallic parts can become energized if a fault occurs, and grounding and bonding them helps to provide a safe path for fault currents to return to the source. The NEC specifies the requirements for grounding and bonding these metallic parts in various sections, including Section 250.96 for metal enclosures and raceways, and Section 250.118 for equipment grounding conductors. When grounding and bonding electrical equipment, it is important to use the correct type and size of grounding and bonding conductors. The size of the equipment grounding conductor is typically determined by the size of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. The grounding conductor must be large enough to safely carry the available fault current without overheating or melting. The type of grounding conductor that is used must also be suitable for the application. For example, insulated grounding conductors are typically required in wet or corrosive locations, while bare grounding conductors are permitted in dry locations. The NEC also specifies the methods for connecting grounding and bonding conductors to equipment and enclosures. These connections must be made with listed connectors or fittings that are suitable for the type of conductor and the type of equipment or enclosure. The connections must be tight and secure to ensure a reliable electrical connection. In addition to the requirements for grounding and bonding new electrical installations, the NEC also addresses the grounding and bonding of existing electrical systems. Section 250.4 FR of the NEC requires that existing electrical systems be grounded and bonded in accordance with the requirements of the NEC at the time the system was installed. If the existing grounding and bonding system does not meet the current requirements of the NEC, it may be necessary to upgrade the system to comply with the current code. This can be a complex and expensive undertaking, and it is important to consult with a qualified electrician to determine the best course of action. The NEC also includes requirements for the grounding and bonding of specific types of equipment, such as generators, transformers, and motors. These requirements are typically found in the sections of the NEC that deal with these specific types of equipment. For example, Section 445.19 of the NEC specifies the requirements for grounding and bonding generators, while Section 450.10 of the NEC specifies the requirements for grounding and bonding transformers. These requirements are designed to ensure that these types of equipment are safely grounded and bonded, and that they do not pose a shock hazard to personnel. Grounding and bonding are essential for electrical safety, and it is important to understand the requirements of the NEC and other applicable codes and regulations. If you are not familiar with these requirements, it is important to consult with a qualified electrician before installing or modifying any electrical system. A qualified electrician will be able to ensure that the system is properly grounded and bonded, and that it meets all applicable safety standards.